Okay, so I'm going to continue.
So let me introduce you for 2 words more. So before we considered high performance cluster and computational chemistry as 2 separate things, because drawing molecules doesn't need powerful computation. And Audrey is the first in our list of speakers who will try to merge these 2 things, computational chemistry and powerful computer clusters.
Yep, I'm going to try and overview that really quickly. Just continuing the idea of optimization, I'm going to talk about these 3 things. So optimization versus electronic structure. Geometry optimization is kind of just the points where at this minimum the potential energy surface, and at the minimum that's where the stationary points on the molecule will fall. And the electronic structure optimization gives information of electrons and orbitals at that energy minimum. So one way to understand this energy minimum is a point where any displacement with respect to the nuclei would lead to an increase in energy up on this curve. And it's also the most stable isomer. So now I'm going to talk about job types. These are a few that we've talked about. Single point energy is where you can get this kind of the default energy calculation on that curve. Geometry optimization will adjust the stationary points of that molecule on the potential surface energy. By default, it's the global minimum. Frequency and thermochemical analysis, that computes force constants, and the resulting vibrational frequencies. We haven't talked about that much. And scan is a potential energy surface scan, and it's consisting of single point energy evaluations over a rectangular grid, and it involves selected internal coordinates performed. We have not talked about that. Force computes forces on the nuclei as well. And these are some other ones found on the Gaussian website. There's a ton of information there if you are interested in there. And now submitting, monitoring, and learning from an optimization job. So these are the commands. A .com file is the one that we always input to run a job. It contains all the necessary instructions to be completed. And then you input run Gaussian with the name of your file.com, and then you get a completion notification if nothing happens, hopefully, and you'll get a job number. So from that, you can use QStat, and that will give you all the jobs that are currently running to get to, if it's an optimization job, all the jobs doing their optimization. And to get yours specifically, you do QStat and then grab job number. And then that's when you get your optimized molecule. And that's my sources.
Okay.